topic for my discussion is milk, and there are all kind of milk available in the market in the form of milkshakes, cheesecake, ice cream, chocolate, yogurt, and cheese, and they have great nutritive value because they contain protein needed for the repair and growth, the calcium needed for good bones and teeth, and the phosphorus needed to release energy, and all kind of vitamins like riboflavin is needed for healthy skin, and other vitamins and minerals which are needed for good health are contained in it. Next, we will discuss the milk composition. So, next we're going to discuss milk composition. So, milk is an oil and water dispersion of fat globules with a suspension of casein micelles, which consist of casein, calcium, and phosphorus, and they are all suspended in aqueous solution. And it also consists of solubilized lactose, whey protein, and other minerals needed. So the milk consists of 87% water, 5% lactose, sugar, the disaccharide, 4% lipid, 3% milk proteins, and also it consists of acids like oxalate, formate, citrate, and vitamins like vitamin A, D, riboflavin, and minerals like calcium, phosphorus, sodium, and potassium, and also the enzymes such as peroxidase, catalase, and lipase. And next we will discuss some of the major components in details. So let's discuss first the milk carbohydrates. So milk carbohydrates mainly consist of lactose disaccharide, which consists of galactose monomer and glucose monomer linked together by alpha-1,4 glycosidic linkage. So some people are lactose intolerant because of lack of the enzyme called lactase, and they are not able to digest the lactose and have all kind of problems. The other sugars present in small quantity are glucose and galactose, and since these are reducing sugars, so there's a tendency that they will undergo Maillard reactions. Next, we will discuss the milk proteins, especially casein and whey proteins in detail. So next we're going to discuss the milk proteins. So the 80% of the milk proteins consist of casein, and then rest of it is the whey protein. The casein are alpha S1 casein, alpha S2 casein, beta casein, and kappa casein. And the whey proteins mainly we'll be discussing will be beta-lactoglobulin and alpha-lactalbumin. So to go over the casein structure in detail, the casein, they are the heterogeneous group of phosphoproteins. Their size ranges from 30 to 300 nanometer, and the quaternary structure of casein consists of 96% protein and 94% protein and 6% small ions like calcium and phosphorus. So the casein micelle structure actually has a hydrophobic core and hydrophilic coat. This is hydrophilic due to the presence of kappa casein, which gives negative charge to the casein micelles, due to which they are able to repel each other and don't undergo aggregation. So to go over the structure of each submicelle, consists of the polar kappa casein regions with hydrophobic core and hydrophilic coat with CMP here, and the two subunits, they are connected together via calcium phosphate clusters. So there are serine amino acids which undergo phosphorylation with phosphate group, and then these phosphate groups are connected to each other by calcium clusters, and hence for stability of calcium, for the stability of casein, micelle structures, calcium and phosphorus are responsible. Next, we're going to discuss the whey proteins. So next, we're going to discuss the whey proteins, in which we will discuss the beta-lactoglobulin and alpha-lactalbumin. So we compare the two. So beta-lactoglobulin is the most abundant whey protein, and it consists of 8 beta-antiparallel sheets, while alpha-lactalbumin consists of 4 alpha helix plus 1 beta antiparallel sheet. And the beta-lactoglobulins, they denatures at 67 degrees Celsius and 6.7 pH, while alpha-lactalbumin denaturates at 63 degrees Celsius and pH less than 4. And biological function of lactoglobulin is to bind small molecules like retinol, and the biological function of alpha-lactalbumin involves lactose synthesis. So next we are going to discuss the coagulation of the protein under different conditions. So next we're going to discuss the milk protein coagulation due to 3 factors: the renin, the enzyme, acid coagulation and heat coagulation. So when the enzyme is added, the coagulation occurs in 3 steps. First, the hydrophilic peptides diffuses away from the micelle, and the hydrophobic peptides are left on the micelle. The secondary stage is these micelles aggregate together due to hydrophobic interactions and calcium bridges. They form the 3D gel. The tertiary stage is that the coagulation involves a rearrangement of the micelles after formation of the gel, and to form the curd is formed and syneresis occurs. The acid coagulation involves the removal of calcium and phosphorus, which leads to the hydrophobic interaction between the micelles and leads to the formation of gel. Heat coagulation mainly occurs only in whey proteins because they have more sustained amino acid, and while caseins are pretty much stable to the heat coagulation, and they don't coagulate or aggregate at high temperatures either. Next, we're going to discuss the milk lipid or the fat globule. So now we're going to discuss the milk lipid, or as called as fat globule in the milk. So the milk lipid 98% consists of triglycerides, and out of which the 2/3 of all the fatty acids are saturated fatty acids. The fat globule consists of mostly triglycerides, but it's covered by the thin membrane, which consists of phospholipid and lipoproteins. And now we're going to discuss the homogenization of milk. Alright, now we're going to discuss the homogenization of the milk. So the fresh milk, if it stays for 12 to 24 hours, then the creamy layer separates from the milk layer. The creamy layer consists of clusters of fat globules which are lighter than water, so they resist to the surface. So to prevent that from happening, homogenization is a good measure. It breaks down the fat globules, and then since there's not enough phospholipid and lipoproteins to cover the surface area, as when the size decreases, the surface area increases. So the casein micelles, they kind of get absorbed on the surface of fat globules and then weighs them down, preventing the clustering and separation of the layers. But due to the exposure of fat globules, there are more tendency of their rancidity to occur. So the pasteurization is also needed to kill the bacteria and to inactivate the enzyme to prevent the rancidity. Hence, the other important technique to kill microorganisms is pasteurization. In pasteurization, the milk is heated for shorter time to kill all the microorganisms and make it more healthier and nutrient for that. Thank you.
So pasteurization का type.
So now we're going to discuss the milk flavors. So due to the formation of sulfur compounds or carbonyl groups or free fatty acids, some of flavors can be resulted into. So there are a number of reasons such as oxidation. The auto-oxidation of lipids can lead to the off flavors, or the rancidity, which is a result of hydrolysis of triglycerides by the enzyme lipases to generate free fatty acids, which can cause rancidity and off flavors as a result of it. Also, the homogenization process, heating and cooling, can also accelerate the rancidity. The bitterness could be the result of proteolytic activity such as from renin enzyme, and also due to the heat treatments there could be off flavors. The low heat treatment leads to the formation of sulfur compounds formation from on heating the whey proteins, which leads to off flavors, and also the ultra high temperature treatment can lead to the fruity ketone type of flavors, and the sterilization can also lead to Maillard reaction and Stracker degradation, which can result in caramelized flavors. That be all about the flavors and the milk.